Thousands of strange spaceships sneak into Earth's airspace. They descend to our planet and fly through cities, plunging people into complete chaos. Suddenly, the door of the largest ship opens, and a strange creature comes out. It tries to copy our language and says they had come from a distant star, Proxima Centauri. Something like this might happen because scientists have recently picked up a strange radio signal off that star. Proxima Centauri is the closest star to our solar system. It's only 4.2 light years away. That means a beam of light that starts from this star reaches Earth in 4.2 years. That's also 270,000 distances from Earth to the Sun. The star Proxima Centauri itself is too pale for us to see with the unaided eye in the night sky, but its system hides a little secret. Let's fly there and take a closer look. So here's this red dwarf. It's 7 times smaller than our Sun and 8 times lighter. Proxima Centauri is 1.5 times bigger than Jupiter and almost 150 times heavier. But what we're looking for is a little further away. This is Proxima Centauri b, a planet similar to Earth. It's only 10% larger than Earth and is in the habitable zone of the star. It's the perfect distance, not too far away and not too close. So the temperature isn't too high or low there either. Water, if it exists on that planet, can be in a liquid state. And so, life can survive and evolve there. Maybe it's developed enough to send us the signal that we had received. A radio signal is basically waves. They have a certain frequency and length, and we can always tell an artificial signal from a naturally generated one. The signal that we picked up from Proxima Centauri b had a frequency of 982 megahertz. The regular radio we listen to in the kitchen or in the car picks up signals around 100 megahertz. That's why scientists have concluded that the signal was created artificially. Such signals could have a way of communication between the developed worlds. If this is really a message from an outer space civilian, we should be able to decode it. For this, any civilization must use the simplest method of encryption. For example, Earth has already sent a radio signal into space. It was the Arecibo message. This message consists of 1,679 digits. It's a rectangle of 23 by 73 squares that has information about our civilization encoded using a binary code. At the top of the rectangle, there's a system of numbers that we use. They're marked in white. This purple thing is the key to read the next part of the message. The atomic numbers of the elements like hydrogen, carbon, nitrogen, oxygen, and phosphorus are encoded in this key. These are the key elements that can start life. If those who receive this signal can make sense of the numbers in the key, they can read the next part of the message. These green things are the building blocks of our DNA chain. And right at the bottom here is the DNA chain itself. The white rectangle indicates the number of pairs of these building blocks, and the blue spirals show the shape of a DNA chain. And then we see the human silhouette itself. The white and blue object to its left is a coded number of our average height. The human itself is drawn here at the ends of the DNA strand, so that the outer space civilization can understand what we look like. And the white rectangle to the right of the human sketch is the number of Earth's population at the time of the message. That's 4.2 billion as of 1974, almost half the number we have now. The next part is a drawing of our solar system. The big yellow square is the Sun. Then come all the planets in our solar system, including Pluto. Earth is shifted up a bit here, so that outer space civilization can understand where this message is coming from. In the last drawing is the observatory from which this message had been sent into space. This signal is now on its way to the M13 star cluster 25,000 light-years away from Earth, so it won't get there for another 25,000 years. And we'll need another 25 to get a response if there is really someone on the other side who can receive the signal. If the signal from Proxima Centauri is also a message, we'll need time to decode it. So let's fire up our super-powered computing machine and wait for the result. But this isn't the first mystery signal we've ever picked up on Earth. Scientists recorded an unusual wow signal in 1977. They supposed it came from somewhere in the constellation of Sagittarius. The telescope was picking up the unknown signal for an impressive 72 seconds. Later, a scientist who looked at the printout of the signal concluded that the signal was artificial. He wrote, "Wow," on the printout as his reaction. The following observations and studies couldn't catch this signal again. Some theories said that this signal came from a celestial spaceship flying by. It had flown away, and we could no longer detect the signal. But most likely, this signal was created on Earth. It was directed upward but reflected off an object at a high altitude. It could have been an airplane, a satellite, or space debris orbiting our planet. Then the signal was picked up by the telescope, and because it was human-made, all of its characteristics, like wavelength and frequency, could have confused scientists. In 2017, scientists recorded a flare on Proxima Centauri. The star's brightness increased by 1,000 times in just 10 seconds. Before that, there was another flare there that was weaker but lasted about 2 minutes. With these flares, Proxima Centauri has emitted enormous amounts of radiation. Even if there was life on the star's companion planet, these flares would have likely destroyed it. The stellar winds would have simply blown the atmosphere off the planet and made its surface lifeless. Overall, the planet Proxima Centauri b receives 60 times more high-energy radiation and 400 times more X-ray radiation than Earth. Scientists have concluded that the probability of life here is 1 to 100 million. And while we don't know yet for sure if the signal was artificial or natural, the scenario of a bunch of spaceships coming to Earth is most likely possible. Our only method for searching for outer space civilizations is using radio waves. They're like loud noise that blasts away from our planet in different directions at the speed of light. The main problem here is the gigantic distances. Our galaxy, the Milky Way, is 100,000 light-years wide. Suppose there's life at the other end of it. If we send a radio signal to them, it won't reach that supposed planet for another 100,000 years. And we won't get a response for another 100,000 years. It's the same if someone once wanted to contact us. We didn't learn how to create and receive radio signals until the 19th century. If a civilization was developing at the same time as us somewhere in the Milky Way and they invented the radio, we won't get their signal for several millennia. Plus, the radio noise from our planet is starting to fade away. We use Bluetooth, fiber optics, cable TV. So in about 100 years, we'll no longer be visible to other worlds. Or worse, what if there was an outer space civilization somewhere that was sending signals into space? The signals were reaching our planet, but we didn't yet have the technology to pick them up. The world that was sending the signal has evolved, and the signal went out. We could have caught those remnants of the radio waves that were moving through the universe, but we set up the antennas too late. There are about 2 trillion galaxies in the universe. Each of them contains billions and trillions of stars similar to our sun. Maybe there's a planet near one of them that looks like ours. Life could be blooming there. And this outer space civilization, just like us, is looking through telescopes in hopes to catch the radio signal from an unknown planet.
Weird, unusual sounds out of nowhere are spreading all over our galaxy, constantly repeating, and it's something we've never heard before. Scientists discovered it in 2020, and it was nothing like any of the other energy signatures they ever studied. Powerful and bright radio signals occurring from time to time, mysteriously disappearing within a day. It doesn't fit the profile of any space body we know. The signal is a bit irritating, and it disappears without a schedule. When scientists tried to match the signal with some other telescopes, it was gone. Low-mass stars sometimes flare up with radio energy, but not here, since they mostly have X-ray counterparts. Very dense collapsed stars, like pulsars and magnetars, are also not a choice. The closest solution they got is a mysterious class of objects we know as the Galactic Center Radio Source, GCRT. It's a radio source that brightens and rapidly glows. It decays near the center of our galaxy and could help us unravel the mysteries of the universe. If you had a flying car that could go up at a speed of 60 miles per hour, you'd only need 1 hour to get into space. The moon is a little bit farther, 250,000 miles, which is about 10 times the circumference of our planet. That means a moon trip would be like taking a tour around the globe and doing it 10 times straight, which would take less than 6 months. A trip to Pluto would take over 800 years. Proxima b is the closest Earth-like neighbor we have. It's a small rocky world that orbits the closest stellar neighbor of our Sun. It orbits the star's habitable zone, an area that's far enough from any star to have moderate conditions, not too cold and not too hot for liquid water to at least hypothetically exist. If you tried to travel to Proxima b at a speed of 25,000 miles per hour, which is the speed of the Apollo moon rockets, it would take you over 112,000 years to get there. You might not be able to breathe there. No one knows if Proxima b has an atmosphere. Humans explore the universe all the time, but we can only see around 5% of the matter up there. And Albert Einstein was the first one that realized the empty space is not really nothing. The rest we can't see is actually made up of invisible matter, also known as dark matter. It's about 27%, combined with something called dark energy, which is 68%. If you try to pour water into space, of course, outside of a spacecraft, it would immediately boil away or vaporize. That's because there's no air or air pressure in space. As air pressure lowers, the temperature you'd usually need to boil water at also gets lower. Keeping that in mind, water boils way faster on a mountaintop than, for example, at sea level. There's no air pressure in space, so water could boil at a very low temperature. Scientists believe that there are at least a couple of billion galaxies out there. We don't know the real number, and probably never will, but they tried to calculate it by counting how many galaxies we can see in a pretty small and restricted area of the sky. It may seem as if the universe was filled with stars and a couple of planets here and there, but our home galaxy has at least 100 billion planets. If you fill a balloon with helium and release it, you'll notice it floats very high. It'll go up into the atmosphere, but it won't go into outer space. The higher you go, the thinner the air in our atmosphere gets. Your balloon will rise up until the point where the atmosphere surrounding it has the same weight as the helium inside it. That will happen at approximately a height of 20 miles above the surface. So this is as far as a helium balloon can rise. We don't really know how big the universe is. We can't see its edges, nor do we know if it even has an edge. We use technology to see out to a distance of around 14 billion light-years from our planet. This means we can see around 28 billion light-years in diameter across, starting with the outermost layer of our atmosphere that ends at around 600 miles above our planet's surface. Although the size of the universe is constantly changing and gets bigger through time. Mercury is closest to the Sun, so most people think it's the hottest planet too. Still, Venus is the hottest planet. It's the second planet away from our central star, around 30 million miles farther from the Sun compared to Mercury. Mercury doesn't have an atmosphere, which is like some sort of a warming blanket that helps maintain the heat coming from the Sun. Venus has an unexpectedly thick atmosphere, around 100 times thicker than the one we have. Its atmosphere doesn't let the heat out, it just keeps it and constantly makes Venus hotter and hotter. Also, it mostly consists of carbon dioxide that freely lets solar energy in. But it's less transparent to lose long wavelength radiations that the warm heated surface emits. The average temperature there is around 875 degrees Fahrenheit, which is hot enough to melt tin. The maximum temperature on its neighbor, Mercury, is 800 degrees Fahrenheit. In maybe 2 or more billion years, it will be way too hot for life to exist on our precious planet. As the hundreds of millions of years go by, our sun will keep getting hotter and brighter. Eventually, temperatures will be so high, our beautiful oceans will be wiped away. Since they produce 70% of the oxygen we need to survive, there'll be no life without them. All of this means that our planet will simply become a vast desert, something like Mars is today. Pluto, a very distant used-to-be planet, now dwarf planet, is actually smaller in diameter than the entire US. The biggest distance there, from Maine to Northern California, is approximately 2,900 miles, while Pluto is only 1,473 miles across. Pluto is very far, but the edge of our solar system is 1,000 times farther away than this dwarf planet. But astronomers found many space objects orbiting our sun way farther than Pluto, such as Kuiper Belt objects and trans-Neptunian objects. There's also an Oort comet cloud that goes half a light year from Pluto, also 1,000 times farther. A neutron star is really heavy. Just a teaspoon filled with it would weigh 6 billion tons. Neutron stars are something that remain from huge stars that have run out of fuel. The fading star explodes, and its core falls apart, but due to gravity, it forms an extremely dense neutron star. These stars typically have a mass of up to 3 suns, but the radius there is around 6 miles, because this is one of the densest things in our universe, at least that we know about. The universe has a color, and it averages to be some kind of beige, or as they call it, cosmic latte. It also has its own smell that reminds you of seared steak or hot metal. At least, that's something astronauts floating in space have said. If you want to build a spacesuit, get ready to work really hard. It takes 5,000 hours to make it and will cost you $1 million. A really good one will have 11 layers of material and weighs about 110 pounds, and it needs to be comfortable. You'll need more space in there because you grow up to 2 inches when in space. When you're floating around in space, Earth's gravity doesn't have any impact on you. That's why the vertebrae in your spine might expand and relax a little bit, which means you'll be maybe 3% taller. For 6 feet, it's about 2 extra inches. Oh, don't worry, it's not permanent. As soon as you go down to Earth, you'll shrink back down to your normal size within a couple of months. Space isn't the best option if you want to have a conversation with your friend, because up there, sound doesn't travel at all. Molecules there are so far apart that sound vibrations can't reach them, which automatically means they can't vibrate, so we can't hear them. Movies are not accurate with this. No one could hear you screaming in space, too. We kind of live inside our sun. The sun is not just that big hot ball of light located 93 million miles away from us. Its outer atmosphere is way bigger. It extends far beyond the surface we can see. Our planet's orbit goes through its tenuous atmosphere. The evidence is when gusts of the solar wind generate the southern and northern lights. That means, in some way, we live inside the sun. Not just us, other planets too, including distant Neptune. The heliosphere, which is what we call the outer solar atmosphere, extends to about 10 billion miles.
Voyager 1, which has been traveling through interstellar space for more than 45 years and is trailing a long gray beard by this time, not really. It suddenly began to send strange signals to Earth. Even more bizarre, there are no signs that the probe has broken or anything. Scientists from NASA are desperately trying to find the reason. So, what's happened exactly? First of all, let me tell you a bit more about Voyager 1 and its long journey. Voyager 1 is an American space probe. Scientists from NASA sent it into space on September 5, 1977. Voyager's goal was to explore the outer planets of our solar system, namely Jupiter and Saturn. Initially, scientists assumed that the mission would take about 5 years. Haha, the joke's on them. The probe exceeded all expectations. Not only did it fulfill its mission, but it's still working for much longer than expected. Voyager 1 has been wandering around space for more than 45 years. It's hard to estimate what Voyager 1 has done for science. Firstly, it successfully sent a lot of photos of Jupiter and Saturn to Earth. By the way, you can even check out these photos yourself. All of them are published on the NASA website. Thanks to Voyager, we also discovered several new moons of Jupiter and a previously unknown system of its rings. We learned that Jupiter's famous red spot is actually a giant superfast storm. And after leaving Neptune's orbit behind, Voyager also sent a lot of important data about interstellar plasma. So Voyager 1 successfully proved to scientists how useful it was. After that, it happily headed for its next goal, the Kuiper Belt and the heliosphere. The Kuiper Belt is a ring of icy bodies that extends from Neptune to a distance of approximately 50 AU from the Sun. It's kind of similar to the asteroid belt, but about 20 times wider and 100 times heavier. And the heliosphere is an area around the Sun where the pressure of the solar wind is balanced with the pressure of interstellar gas. Yeah, I know, it sounds like some hard scientific stuff. Just keep in mind that this data really helps us understand the universe as a whole. So, this is Voyager's last task, to tell us more about interstellar space. The probe has already sent us more than 60 frames for a mosaic of the solar system from a distance of over 4 billion miles from Earth. Scientists used these frames to make a big colored picture. The photo was called the pale blue dot, and you've probably already guessed what that dot is. Yep, that's what our Earth looks like through Voyager's eyes. This photo clearly shows how tiny we really are, and how precious and fragile our planet is. But Voyager 1 also has another, even more important mission: to tell other civilizations about us humans. You might have heard about the famous Voyager Golden Records. People created many audio and video files and added them to these records. There are a few sections. The first one contains hello in 55 languages, including ancient and extinct ones. Almost 80% of the recordings are different musical pieces, like Bach, Beethoven, Mozart, and Stravinsky, folk music from different countries and ages, and a bit of the blues, like famous songs by Louis Armstrong and Chuck Berry. The remaining 20% of the recordings contain different human voices, sounds of nature and animals, as well as 116 images encoded as audio signals. There's also recordings of speeches by Kurt Waldheim, a former UN Secretary General, and Jimmy Carter, a former US President. These are just some friendly messages. In addition to the records, scientists also packed a needle for playing them. Don't worry, they also left a simple drawing that showed how to use all this stuff and how to translate the sounds into pictures. They added Earth's coordinates, which they created using a pulsar map. It shows the position of the Sun in the Milky Way. The record was packed in an aluminum case and covered with gold to protect it against radiation and cosmic dust. Carrying this record, Voyager 1 set off on its long journey, and it has already traveled quite a distance, I'd say. Right now, Voyager 1 is 154 astronomical units away from us. That's about 14.5 billion miles. This makes it the most remote human-made object. Initially, this title belonged to the Pioneer 10 mission, but Voyager overtook it in 1998. What a bargain for NASA! It's way beyond its best-by date. Voyager 1 is actually so cool that it even overtook its twin brother, Voyager 2, which, by the way, had been sent into space 2 weeks earlier. Voyager 1 moves at a speed of 9.7 miles per second. That's 35,000 miles per hour. Even the fastest sports car in the world travels at a speed of only 305 miles per hour. So it's hard to imagine the speed of Voyager. Anyway, at the moment, Voyager is heading to the borders of the Oort cloud. That's the name of a hypothetical layer of icy objects surrounding the solar system. Astronomers haven't confirmed its existence yet, but they're almost sure it's there. After all, even black holes were only a theory not so long ago. Unfortunately, Voyager 1 won't return back to the solar system. It'll keep in touch with Earth at least until 2025. But eventually, we'll lose the connection with it for good. In 300 years, it'll reach the borders of the Oort cloud. And in 30,000 years, I won't be around then, it'll finally leave the solar system. And if nothing happens to it along the way, in another 10,000 years, Voyager 1 will approach red dwarf star Gliese 445 in the Giraffe constellation. In the future, the probe will probably keep wandering around the Milky Way galaxy. And now, let's finally discuss the mysterious signals part. So, what happened? Well, a rather unusual thing. NASA's Jet Propulsion Laboratory, which monitors and controls both Voyagers, reported this problem in May 2022. Our veteran spacecraft suddenly began sending strange data to Earth. The whole situation puzzles even engineers from NASA. Now, I bet you're thinking, come on, the thing just probably broke down or something. But the truth is that Voyager 1 is totally fine. It works as usual, receives and carries out commands from Earth, and collects and sends scientific data. But the readings of the AACS, which stands for Attitude and Articulation Control Subsystem, don't show what is actually happening to Voyager anymore. This system supports the orientation of the probe in space and helps it keep in touch with Earth. So, basically, the signals mean that the probe's orientation in space is messed up. But scientists claim this is not the case. They know that the source of the antenna signal remains in the same position relative to Earth as planned. The problem hasn't triggered any of the onboard fault protection systems. The probe hasn't even entered safe mode. So, what in the world, or universe, is going on? Suzanne Dodd, the head of the project, says that the problem is not actually that unexpected. After all, Voyager 1 is already 45 years old. The expert admits that what's happening to the probe remains a mystery to them. They don't know exactly where the incorrect data is coming from, and it's unclear how this will affect the operation of Voyager. She adds, though, that it's not that surprising, considering that the probe is in interstellar space. There's a very high level of radiation there. No spacecraft has ever reached that point before. Scientists from NASA say they'll keep closely monitoring the data coming from Voyager 1 until they figure out the problem. If they find it, the management team will try to fix it. Otherwise, the team will have to adapt to the new conditions. It might not be enough just to understand the problem, though. It takes as much as 20 hours and 33 minutes to receive the signal from Voyager, and it takes the same amount of time to respond to it. Well, at least the second spacecraft, Voyager 2, is totally fine, even though it's also currently in interstellar space at a distance of 12 billion miles from Earth. Anyway, we can only wait for news and hope that the problem will be resolved. I actually wonder how much longer can Voyager 1 last? Will it be able to fly to the borders of the Oort cloud in 300 years? What do you think? I'd like to hear your thoughts in the comments.